Hello, everyone. We are the Autopilot dashboard team, and we're going to go over our sprint four. Autopilot is a Kubernetes native daemon that continuously monitors and evaluates GPUs, network, and storage health, and is designed to detect and report infrastructure level issues during the lifetime of AI workloads. It is an open source project developed by IBM Research. Our vision is to develop a fully functional UI dashboard for all Autopilot integrated with GPU-equipped OpenShift's Kubernetes cluster. The dashboard will allow administrators to monitor cluster status, initiate health check tests, and view real-time results within an embedded terminal window.
So we first set up Autopilot deployment and Autopilot dashboard deployment on an active NERC cluster. So we wrote an issue on the NERC repository to get Autopilot deployed and to have a service endpoint exposed for Autopilot. At first, the service endpoints for Autopilot and Kubernetes were not accessible through the browser as they're internal. So we had to add a proxy to our Nginx server configuration so that our front end dashboard could hit the proxy and the proxy could just forward that request to the internal service endpoint and send back the response. Originally, we also did not have access to read nodes using the Kubernetes API, so we had to set up a service account with specific permissions to read nodes, and then we had to take this service account's token and pass it into each API request we made for the Kubernetes API, pass it in as authorization. So we see the app is deployed on a live link on the NERC OpenShift, and you see I selected a test, and I can search node worker nodes right now as shown, which is a new feature. And I run the test. This is similar functionality to what we've shown in the previous sprint, but the main difference is this is a real life AI ML cluster. And if we see the embedded terminal results, we see the results of the test. And this proves that our application works on a real AI ML cluster.
For the monitoring page, we added pagination to select the number of nodes to show per page, along with selecting the specific page. We also added URL parameters to match the search input and the filters we choose.
We also filtered to display information for worker nodes.
So this video shows just the implementation of pagination, selecting how many items you want, along with going through each of the pages. So when we select this specific filter, it also changes the URL to match. Then when we search for worker 107, it also changes the URL.
So for the login page, I started out everything locally. Here I'm showing that the npm server and the Docker file are running. And from then I log in with the dummy user account I made, and I named both the username and the password as John Doe. Once you go into once you log in, it doesn't immediately go into the monitor cluster, so you could just press it on the sidebar, but it shows that like everything works functionally and you're able to sign out properly because I made some changes inside the sidebar.
Yeah, so for login page, we also set up protected routes for our app based on login status to avoid users access page say should not access to. So includes that if only authenticated users can access the monitoring page. If the user is not logging successfully, an error message will show when we click on the monitoring, and a button can be clicked to redirect to login. Also, only authenticated users with admin role can access to test page. If users are not the admins, So an error message will show on the test page and the button can click to the login page. Also, so for the login page, we show a login box component if the users still do not authenticated. If the user log in successfully, then they will show login successfully and with a red buttons where we can click and log out.
For a quick review, so Kubernetes Watch API is an extension of the Kubernetes API with the through query. It provides a real-time update on Kubernetes objects such as nodes. So on the previous sprint, we were able to implement this to display node names. And for this sprint, we are able to display more node information. Furthermore, instead of having multiple methods to fetch node information, it is now done through a single watch stream method that is shared with the monitoring and testing page. And as mentioned previously, service account is now used as authorization.
We also did some refactoring for our styling. We now have a centralized styling, so we moved all of our inline styles to a dedicated styles.js file for easier maintenance and consistency across components. We did this to improve our readability. So the centralized styling improves the readability by separating styling from component logic. It makes it easier to track style changes. And it also made it a scalable and maintainable code base as we created a single source for styles, which enables easier adjustments and scalability if new components are added. And here's our burn down chart for our previous sprint. As you can see, we went into the negatives again because our team members spent more time than expected on each task.
This is what we did for the current sprint. We didn't build the image for Autopilot because it wasn't needed since we didn't make any changes to Autopilot. And the login page hasn't been completed yet because the mentors wanted us to go straight to our stretch goal and implement the login with OpenShift authentication. And that has been harder than we thought it would be. For the backlog of the next sprint, we're on track to complete our full backlog since we don't have a lot of tasks left to do.
In terms of challenges encountered with our NERC autopilot deployment, as mentioned, at first the app could not be, as the deployed app could not hit the internal autopilot and Kubernetes endpoints. And we initially thought that this was because our app was not on the same cluster as Autopilot and as like the live AI ML cluster. But then we did some testing and then we noticed the pods, which the app was being hosted on, the pods themselves were able to hit the internal service endpoints. So then we realized that the reason why the app couldn't hit the endpoints was because it was making the requests through the browser and not through the actual pods, the server, right? So the way to fix this was basically set up a proxy, which we can do using our Nginx server configuration, and use this proxy to act as a mediator and basically forward browser requests to the internal service endpoints. Another challenge we faced was, at first we figured this out, but the problem we were having was we could not pass in query string parameters. And the easy fix to this was just including a trailing slash to our Nginx configuration file syntax. And this we found it would allow the full query string parameters to be passed through.
We also encountered challenges when implementing the Kubernetes API watch. So initially, the plan was to establish a robust continuous stream using WebSocket, but this was not possible because kubectl proxy does not support WebSocket. Instead, we implemented an alternative approach, which was to open a continuous stream, process the data in chunks, decode those chunks, and use a callback function to update nodes in real time based on events. Furthermore, we had trouble displaying worker nodes only because node row labels have empty values. So because of this, we filter the worker nodes based on the node names. So node names that start with CTL are master nodes, and then those that start with WRK are worker nodes.
terms of lessons learned for the NERC MOC deployment, we learned that the apps they send requests, the front end apps they send requests through the browser and therefore they don't have access to internal service endpoints. And we also learned through our research that Nginx server configuration can act as a reverse proxy to forward client requests to their appropriate internal endpoints using the specific proxy pass syntax. And as mentioned before, the initial reason why we thought that our app couldn't hit the internal endpoints was because we thought that it wasn't on the same cluster as Autopilot and the NERC AI ML cluster. But this turned out not to be true. It did turn out that we could hit the same endpoints using the proxy without redeploying our app on the same cluster. So this taught us that we always need to test and verify any assumptions that we have.
Regarding the Kubernetes API watch, we learned that Kubectl proxy does not support WebSocket and that it's possible to have node labels with empty values, so it's always important to check.
For the login implementation, I learned how to configure Keycloak in the console, and that includes admin setup and creating many test accounts. I also learned the required fields I needed to set up Keycloak for our application, and these would be the client ID, secret, and client secrets and redirect URLs.
Some feedback we got this sprint for our testing page is to include a loading icon. So once the run test button is pressed, we want to have a loading icon so the user knows that the tests are just running in the background. And for now, our mentors have told us to disable the run test functionality until our login and protected routes are finished.
So for the login part, our mentor told us that we need to skip straight to implementing stretch goal of OpenShift loading integration. Also, once the user is authenticated, they should immediately be directed to the mentor monitor page. But currently, we do not do this. Also, the login page should not show the sidebar when the user is not logged in successfully.
For the next steps in Sprint 5, we're going to address the feedback from the previous slide and continue to perform refining and testing by improving the Watch API to handle errors in network interruptions. And we're going to add logic to and resource version to track events as well as to resume watch from the last known state. We're going to finish login implementation by integrating OpenShift login with Keycloak and finish protected routes and login styling. Add the Autopilot dashboard image to the Autopilot Helm chart. Continue to continue refactoring application and adding to documentation, and then perform our stretch goals like display recent test history and allow for recent tests to be rerun. Thank you for tuning into our Sprint 4 demo.
Yay!